Hello everyone. So today we are going to see about the solid principles followed in software development. So solid principles is nothing but these are the principles which are followed while designing our software. So while designing our classes and how they are organized, we need to follow the solid principles. So the solid is nothing but it's an abbreviation of each principle. So each letter indicates separate principle. So these are solid principles. So why we are following solid principles? So these solid principles are followed to obtain maintainable and scalable or extensible code. So maintainable code means uh, we should be able to reuse the code. We should not um, write the duplicate code. So if we follow the solid principles, it will be easily maintainable. Not only that, maintainable means other things also come like it is maintainable in the sense if any new feature comes also it will be easily addable, so that's maintainable, and it should be easily testable, and for if we introduce new thing also, the new thing only need to be tested, the old things remain the same, so that is maintainable. It's easy to test and everything comes easy, so that is maintainable. And scalable means if any new feature comes also, we should be able to add to that code. So our code will become extensible if we follow these solid principles. So when I come extensible, here comes the uh, word like the this way. If we follow this solid principles, our code will become loosely coupled. So loosely coupled means so we have tightly coupled and loosely coupled code. So tightly coupled means each and every module will be tightly coupled. That means dependent on other modules which are inside it or following it. So it should not be like that. It should be loosely coupled. Then only it will be easily extensible. Okay. So this is about solid principles. We will see each solid principles one by one now. So solid principles. So as I already told, it is an abbreviation of each principle. So here, so each letter indicates each principle. So we have 5 letters. So we have 5 principles. So S stands for single responsibility principle, or we can say SRP. O stands for open for extension and close for modification, OCP. And L stands for list cost substitution principle, LSP. I stands for interface segregation principle, ISP. And D stands for dependency inversion principle, DIP. So we will see each and every principles in a detailed manner now. So first I will explain about SRP. SRP means as the title suggests, it is single responsibility principle. That means each class should have only a single responsibility. So this is very subjective. So in each based on our requirement, this responsibility may vary. So in other words, what we can do is a class should be there should be only one reason for a change in a class. So that means there should be only one reason for a change in the class. If you are making any change in the class means there should be only one reason. So for example, if we are having a class which is uh, which is maintaining the accounts and finance of a company means in future if we there is some formula inside that calculating the accounts, there is some change in the formula means we should not change the main class. So we should segregate the calculating class, that formula, into a separate class, so that it will be single responsibility principle. So that is single responsibility principle, and it is subjective. It varies depending on our requirement. So that is SRP. So now we are going to see about the next uh, principle. So that is OCP. OCP means open for extension and closed for modification. As the name suggests, uh, you should not change the existing code for introducing a new feature to the code. So that is closed for modification. So we should not touch the existing code if we need any new feature to be added. There may be slight uh, changes we may add, but it should not be entire code changes. And open for extension. Open for extension means instead writing the whole code, we should write in such a way that instead of rewriting the code, if we introduce a new feature, instead of rewriting the code, initially itself we should write a code such that it should be extendable. In future, if new thing come on, so it should not be we should not change the existing code. That way we should write the code. So this can be achieved by introducing interfaces. This can be achieved by introducing interfaces. So let me give a simple example for this. So I will create a new file for demonstrating the example. So consider we are writing some class which is responsible for showing the notifications in our mobile. So in mobile we usually get the pop-up or some notification from WhatsApp, Instagram when it is logged, right? So I'm going to write a class for uh, monitoring that notification, responsible for showing that notifications. So what I am going to do is I am going to write a class which is mobile notification class. There I will, so I may have many type of notification, like WhatsApp notification, SMS notification, Facebook notification, like this. So I am introducing new pointers, and whenever Facebook notification come, I will use this pointer and I will make use of its functionality, and I will do the pop-up in the mobile. So if in future if I get any other new uh, what is it new application in the mobile, so someone is introducing some Instagram, so uh, they will write another classes Instagram notification. Inside this mobile notification, to enable this Instagram notification, what I need to do is I need to have this Instagram notification pointer also to uh, handle this Instagram notifications. So I am touching the existing code, but what the OCP says is we should not touch the existing code if we have a new feature. So this is whatever I have done is violating the OCP. So how it can be avoided is this can be achieved by introducing interfaces. So by simply introducing interfaces, uh, we can we do not, by simply introducing interfaces, we don't violate this rule. So so this is the first approach. Okay, so let's consider the second approach. I'm showing the second approach. So instead of creating separate class for each notification, what I'm doing is I'm creating an interface for notification, and each WhatsApp, SMS, Facebook, Instagram should should be implemented from this interface. So inside this mobile notification handler, I just simply use iMobile notification. So in future, so in future, instead of having separate data type, simply with this interface, the pointer, I can handle any type of notification if it is implemented from this interface. So in future, if I get any so consider this Instagram is not there now, and future if it got introduced also, I will implement from my mobile notification, and I can use the same pointer. So I'm just introducing new code, but I'm not touching the existing code. So this is OCP.